Imagine looking up and seeing a fighter jet flying far higher than it ever needs to. That jet is the MiG-29, a machine built for frontline battles, yet now it is touching the edge of space, where the sky turns black and the Earth curves beneath it. But this strange climb was never part of its mission, and that mystery is the real danger. How could a powerful Soviet fighter unlock a capability no one ever expected? Stay with this story, because the truth reveals a hidden design secret that surprised even Western pilots. When the Cold War reached its most uncertain years, the Soviet Union faced a problem it could no longer ignore. American jets were beginning to rewrite the rules of air combat, and every new test flight from the West sent a clear warning across the world. The F-15 Eagle showed that the United States could dominate long-range battles with speed, radar power, and high-altitude control. Its success pushed fear into Soviet command rooms because nothing in the Soviet inventory could match that combination. Before the Soviets could catch their breath, two new American prototypes appeared: the YF-16 and the YF-17. These lightweight fighters proved that the West would not only control the skies far away, but also win fast, close-range fights with cheap and agile aircraft. Together, these jets formed a dangerous picture of the future, and the Soviet generals knew they were falling behind on every front. Older Soviet fighters like the MiG-21 and MiG-23 struggled in real Middle Eastern conflicts, and their weaknesses were suddenly exposed to the entire world. Their radars had short range, their maneuvers were limited, and their design belonged to an earlier era of air combat. If nothing changed, any future war in Europe would begin with NATO taking control of the skies within hours. This threat forced Soviet planners to rethink their strategy from the ground up. They decided to split their air force into two layers, each built for a different role. The upper layer focused on long-range defense and gave birth to the Su-27, a large fighter built to challenge high-altitude intruders. The lower layer demanded a smaller, tougher machine that could fight close to the front lines and take off from damaged runways. This job was given to the MiG Design Bureau, a team known for creating fighters that were simple, reliable, and deadly in short-range battles. Their task was not to build a luxury aircraft, but a war tool that could launch quickly, fight aggressively, and survive rough conditions. The Soviets expected battles in Europe to begin with almost no warning, so the new fighter needed a short takeoff time and a design that young pilots could learn fast. It also had to operate from improvised airfields because long concrete runways would be the first targets in a real war. All of these fears and expectations shaped the MiG-29, turning it into a machine built for speed, toughness, and mass production. The jet had to be strong enough to fly from grass or broken pavement, yet agile enough to defeat NATO fighters in close-range engagements. This idea created an aircraft that did not just meet Soviet needs, but grew into something more powerful than its creators ever imagined. The choices made for European combat would later lead to an unexpected discovery, one that pushed the MiG-29 far beyond the role it was designed for. And that raises the next big question. What hidden engineering details inside the MiG-29 allowed it to climb into air so thin that the sky itself begins to turn black? The MiG-29 became famous for its extreme agility, yet very few people understand that its strength comes from a collection of design choices that were never meant to send it toward the edge of space. The real story behind this aircraft begins with the way its body interacts with the air around it. The engineers designed large extensions beside the cockpit called leading-edge root extensions, and these surfaces control the airflow during sharp turns at high angles. The extensions create powerful vortices that keep the wings fed with smooth airflow even when the plane points sharply upward. This effect allows the jet to remain stable while pulling tight maneuvers that would cause many other fighters to lose control. The wide blended shape of the wings connected to the fuselage is another hidden advantage because the plane gains lift not only from the wings but also from its entire body. This blended design helps the aircraft handle sudden changes in direction, and it gives pilots more confidence in close-range fights. The twin-engine layout adds even more stability, and the engines sit far apart to increase the chance of survival if one system suffers damage. The space between the engines channels the airflow in a way that produces extra lift, and this lift reduces the load on the wings during aggressive maneuvers. The engines themselves are responsible for much of the MiG-29's surprising performance in thin air. Each power unit is a Klymov RD-33, and this model is known for strong thrust, fast acceleration, and reliable operation at high altitude. The engines can push the aircraft beyond Mach 1 with ease, and they maintain consistent power even when the air becomes cold and thin. This ability gives the jet a wide flight envelope, which means it can operate comfortably at different speeds and altitudes without losing stability. The designers also knew the plane had to fight from damaged runways, so they created a clever air intake system that protects the engines from stones and debris. During takeoff from rough surfaces, the main intakes close and auxiliary doors on the top of the fuselage open to feed air safely into the engines. This simple feature prevents foreign objects from damaging the blades, and it makes the jet extremely reliable in harsh environments. The use of composite materials in the airframe reduces overall weight, and lighter construction means faster climb rates and better acceleration. The structure can handle intense forces during rapid turns, and pilots trust the frame even when pushing the aircraft close to its physical limits. The control system relies on mechanical and hydraulic parts that respond quickly, and this setup gives pilots a direct feel for the aircraft during dogfights. The cockpit is fully pressurized and designed to support high-altitude operation, and when combined with a pressure suit, the pilot can survive flights in extremely thin air. The entire design shows that every part of the aircraft works together to produce a machine that behaves like a much more advanced fighter than its age suggests. These features were created for combat close to the ground, yet they accidentally gave the MiG-29 the strength needed to climb far beyond normal expectations. The jet can hold stable airflow at steep angles because of the wing extensions, and it can keep strong thrust because the engines resist power loss in thin air. The structure stays firm under heavy stress, and the aerodynamic shape provides lift even when the air becomes weak. This combination turned the MiG-29 into a machine capable of sudden climbs that reach heights where daylight begins to resemble space. The engineers did not plan for this result, yet their choices produced a fighter with potential far greater than its mission required. These hidden qualities later surprised even the Western pilots who tested captured aircraft and studied their unusual performance. And this leads to a much bigger mystery. How did these engineering traits allow the MiG-29 to perform the strange upward leap that carried it to altitudes where stars become visible in daylight? The MiG-29 never truly flies at 70,000 feet because the air at that height is far too thin for normal wings to work. It reaches that altitude through a dramatic move called a zoom climb, and this technique uses speed and momentum instead of steady lift. A zoom climb begins with a long acceleration at medium altitude where the air is dense enough for the engines to deliver strong thrust. The pilot pushes the jet beyond Mach 1, and in many tests, the MiG-29 passed Mach 1.2 or even Mach 1.6 before the climb began. The aircraft gathers enormous kinetic energy during this run, and that energy becomes the fuel for the leap upward. When the speed reaches the ideal point, the pilot pulls the nose sharply toward the sky, and the jet begins to rise in a steep arc. The flight path looks like the beginning of a suborbital launch, and the jet follows a curve that resembles the motion of a small rocket. The engines continue to produce thrust, yet most of the climb comes from the speed gathered earlier. As the jet rises, the air becomes thinner, and the control surfaces respond more slowly, but the aircraft keeps moving because the momentum is already locked in. The climb lasts only seconds, yet those seconds deliver the jet into a world that feels nothing like normal flight. When the MiG-29 reaches its highest point, the blue sky fades into a deep black, and the pilot can see stars shining even in daylight. The sunlight becomes sharper, and the horizon curves gently across the edge of the Earth. This moment is brief, but it stays with every pilot who experiences it because the aircraft is balanced between the sky and space. At the top of the arc, the jet almost hangs in the air before gravity begins to take control again. The nose dips forward, and the aircraft starts its return toward thicker air where the wings regain their lift. The whole sequence demands perfect timing, and pilots describe the experience as a controlled fall mixed with a feeling of weightlessness. The Soviets never advertised this ability, yet it became well known among test pilots who studied the aircraft's extreme performance envelope. After the collapse of the Soviet Union, the secret reached the public when the Sokol factory opened high-altitude flights for paying visitors. These flights cost between $15,000 and $30,000, and they attracted people from around the world who wanted to see the Earth from near space. The jet used for these rides could reach speeds close to Mach 1.8 before the climb, and the pilots performed aerobatic moves such as tail slides, barrel rolls, and high G-turns. The experience impressed everyone who tried it because no Western fighter ever offered a commercial program that combined raw power with a view of the planet from such a unique angle. The zoom climb became the MiG-29's unexpected signature, and it showed how a machine built for battlefield missions could touch the edge of a completely different world. The moment the jet crossed into thin air proved that the aircraft held far more potential than its creators ever imagined. The climb also revealed the deep connection between engineering choices and surprising results. This mix of aerodynamic skill, engine strength, and structural endurance turned a frontline fighter into a machine that could almost reach space. The story of the zoom climb makes one question how many other hidden abilities remain inside aircraft designed for conflict, and this mystery leads to a bigger question that shapes the next part of the story. If the MiG-29 could climb so high, what did it mean for its true strength in close-range combat? The MiG-29 earned its reputation in close combat because it carries systems that work together in ways most pilots do not expect. The key to this strength begins with how the aircraft finds its targets without revealing its location. The jet uses an infrared search and track sensor that detects the heat of other aircraft, and this system works without sending out any signals. The sensor allows the pilot to scan the sky silently, and it helps them find opponents who think they are hidden. Western pilots often describe this as a form of passive invisibility because the MiG-29 can watch without being watched. This advantage becomes even more powerful when combined with the helmet-mounted sight, which lets the pilot aim missiles simply by looking at the target. The system reads the movement of the pilot's head, and it links the direction of the eyes to the weapon's guidance path. This gives the MiG-29 a reaction speed that shocked many Western test pilots who had never seen a fighter lock onto a target so quickly. The combination allowed the aircraft to attack opponents even when they were far off the nose, and this opened new possibilities during sharp maneuvers. The R-73 missile became the perfect partner for this sight because it can track targets at wide angles and turn rapidly in flight. The missile responds fast to changes in direction, and it can continue to chase an aircraft even when the target moves to the side. The weapon's agility makes it extremely dangerous at short distances, and it became one of the most respected short-range missiles of its time. The MiG-29 supports this missile well because its airframe stays stable at low speeds, and this stability helps pilots hold tight turns. Many Western fighters lose control airflow at very low speeds, but the MiG-29 keeps its nose pointed exactly where the pilot wants. This behavior gives the pilot more options during intense dogfights, especially in moments when both aircraft are fighting to gain the better position. The jet can also perform dramatic moves that help it shake off an opponent, and one of these moves resembles the famous maneuver seen on the larger Su-27. The MiG-29 version is not as extreme, but it allows the aircraft to change direction suddenly, and this sudden move often surprises the other pilot. The frame can handle a force of 9 times the weight of gravity, and this resilience gives the pilot confidence to push the jet close to its physical limits. The high G resistance lets the fighter stay tight inside a turning circle, and this position is vital when trying to place another aircraft inside the weapons range. The cockpit layout helps the pilot stay aware during these demanding moments, and the controls respond quickly and predictably. These traits created a jet that dominated close engagements and training exercises between expert pilots. The aircraft's agility impressed air forces that tested it, and many reports confirmed that the MiG-29 could match or challenge Western fighters in the hands of a skilled pilot. The plane's shape also plays a quiet role in these battles because the design keeps airflow stable across the surfaces, and this stability helps the jet avoid unwanted spins. The engines contribute strongly to its performance by delivering reliable thrust during sudden changes in direction, and this gives the pilot more control. The fuel system supports short, intense bursts of power that are often needed when trying to force an opponent out of position. All these elements make the MiG-29 one of the most respected short-range fighters of its era, and many pilots consider it a dangerous opponent in any close encounter. Yet this strength opens a new question about its history. If the MiG-29 was so capable in close combat, why did it suffer so many losses in real wars? The MiG-29 showed remarkable skills in close combat, yet its record in real wars tells a very different story. The main reason is that combat success depends on far more than aircraft design, and the MiG-29 often entered battle with several disadvantages. The first major weakness came from its radar system, which used older technology that struggled to detect distant targets. The radar worked well at short range, but long-range tracking required more advanced processors than the MiG-29 carried at the time. Western aircraft had stronger detection systems, and they could spot a MiG-29 long before the MiG-29 could spot them. This early warning advantage allowed Western pilots to prepare for battle, while the Fulcrum pilot flew blind in comparison. Electronic warfare made the problem worse because the MiG-29 struggled to resist jamming signals used by modern air forces. Western aircraft carried advanced countermeasures that interfered with Soviet radar, and this interference made it difficult for the MiG-29 to lock onto distant targets. Many engagements began with the MiG-29 already at a disadvantage because its onboard systems could not filter out the electronic noise. This weakness became clear during battles where Western jets coordinated their attacks through shared radar networks. The second major issue appeared in the quality of missiles used in these conflicts, as the R-27 missile often failed to perform reliably in real combat. The weapon could lose its target easily, and pilots reported that the missile sometimes broke its lock for reasons they could not explain. The structure beneath the surface looked sharper, more defined, as though something had shifted while hidden behind the sun. And the narrow jets that once acted like directional bursts appeared stronger, firing in a pattern different from before. The truth was that the weapons simply did not match the performance of Western missiles, which had better sensors and more reliable tracking. The next problem came from the condition of the aircraft flown by export users, who often faced shortages of replacement parts and trained technicians. In several conflicts, the MiG-29s entered battle with incomplete systems, worn engines, and limited maintenance support. Some jets had damaged sensors, and others had outdated software that reduced their performance in critical moments. The pilots received fewer training hours than their Western opponents, and this lack of practice made it harder to use the aircraft's full potential. Many export operators also lacked access to airborne warning and control aircraft, which coordinate battles from long range. Western forces relied on these support planes to guide their fighters and share information across the battlefield. MiG-29 pilots fought without this guidance, and they had to rely only on their personal radar and visual skills. This difference created an uneven playing field, and the aircraft lost many encounters before the pilot even realized the threat was approaching. The Gulf War showed these weaknesses clearly because Iraqi pilots flew poorly maintained jets with limited fuel and outdated avionics. The Fulcrums were quickly defeated by American and coalition aircraft, which used better sensors and stronger coordination. A similar pattern appeared during the conflict in Yugoslavia, where MiG-29s faced Western aircraft supported by powerful radar networks. Several MiG-29s were shot down before their pilots could fire a single effective shot, and this result damaged the aircraft's reputation worldwide. These defeats did not reflect the true potential of the MiG-29, because the aircraft performed poorly only when surrounded by weak systems and limited support. When flown by skilled pilots with proper maintenance, the aircraft proved much stronger in controlled tests. The real lesson from these conflicts is that a fighter jet is only as effective as the network that supports it. The aircraft needs strong radar, reliable missiles, trained pilots, and coordinated command to reach its full capability. All these factors explain why the MiG-29 looked powerful on paper but failed in real combat under many export users. Yet the story does not end with failure, and the next part of this journey reveals how global powers wanted to study the MiG-29 more closely. If the aircraft struggled in war, why did the United States and Israel work so hard to get their hands on it? The MiG-29 struggled in many real wars, yet the world's top militaries were still desperate to study it up close. This interest showed that the aircraft held secrets that could change how Western pilots prepared for future battles. The story began in 1997 when the United States quietly purchased 21 MiG-29s from Moldova. The deal happened fast because American officials feared that Iran might buy the jets first. Once the aircraft arrived in the United States, they were taken apart and shipped to an air base in Dayton, where engineers examined every system. The goal was simple because the United States wanted to understand the jet's agility, test its radar resistance, and compare its performance to American fighters. The aircraft became valuable test platforms for missiles like the AIM-9X, which needed to prove they could defeat highly maneuverable opponents. These tests helped American pilots learn how a MiG-29 moved during tight turns and how its engines reacted under pressure. Israel followed a similar path because Israeli pilots faced Soviet-built aircraft many times in their region. Israel secretly borrowed MiG-29s from Eastern European partners and put them through a wide range of tests. Their pilots focused on low-speed reactions, narrow-angle turns, and high-stress maneuvers that pushed the aircraft toward its physical limits. The results surprised them because the MiG-29 matched the performance of F-15 and F-16 when flown by experts. Israeli pilots later stated that the aircraft offered unique handling qualities that required new strategies during close combat. These findings changed how Western air forces trained because they realized that the MiG-29 could be a serious threat if supported by skilled pilots and modern equipment. Many nations also continued improving the aircraft, creating new variants that added stronger avionics and new roles. The MiG-29 SMT, MiG-29 UPG, and MiG-29K introduced better fuel systems and advanced weapons that kept the design relevant. The final version, known as the MiG-35, pushed the airframe into a modern generation with updated sensors and multi-role capabilities. These upgrades showed how much potential the Fulcrum still held even decades after its first flight. The aircraft remained one of the most closely examined fighters in the world because its agility continued to impress engineers and pilots. All these discoveries lead to a final question that ties the entire story together. If a frontline fighter built in the Cold War can still surprise the most advanced militaries on Earth, what else might its hidden design still be capable of? The MiG-29 began as a frontline fighter, yet it proved to be far more than a simple tool of war. Its powerful engines, clever aerodynamics, and bold engineering allowed it to climb toward the edge of space, a feat almost no other jet of its time could match. Its close-range skills, helmet sight system, and high off-bore sight missiles shaped how modern fighters approach dogfights today. Many newer aircraft, from the F-22 to the Rafale, still use ideas first tested on the Fulcrum, including blended lift surfaces and advanced heat tracking sensors. The MiG-29 left a legacy that influenced the design of air combat aircraft, causing humanity to discover many surprises.